Hello, everyone. My name is Anthony. Today, we're going to see how to build Retrieval Augmented Generative AI. So I'm just going to take you through one slide, and then show the demo of how the one I already built, how it works. And then, so after the demo, I will take you through the code to show you how everything was put together. Okay, so I'll share my screen. So so here we see here Retrieval Augmented Generative AI. So this is how this kind of framework that I used to build this. So you have so in the demo I'm going to show you, I have the PDF. It accepts PDF. You know, you can actually put in PDF, and then um, it will break the PDF into chunks here, and then try to put them into embeddings, and then store those embeddings in a vector store, like a database, where here we're using Chroma database. And then you can actually put in a YouTube video, like a YouTube link. It's going to convert the YouTube video to audio, then from the audio, you're going to convert it to test. That's the speech test to get a transcript. And then when it gets a full transcript, break it into chunks, splits it into chunks, and then get embeddings of those chunks, and then store in this place, in the vector store here. So the same thing goes with the web page, like a blog, get a test, splits into chunks, embeddings, and store in the store. Okay, so that is this pipeline. And then when a user is actually wants to query this this system, a user will send a query, and the query of the user is going to be converted to vector, and then there's a conversational chain. In the conversation chain, you have a retrieval chain that's going to retrieve is going to retrieve the document from the vector store. So the retriever. So in the conversation chain, you have the retriever. The retriever, we use kind of let me say a search type, which can be similarity, to check the vectors that have the closest distance between what you're asking and what is available there. So it's going to pull out those data from the database, and then it's going to pass it through the LLM, which is a chat model. So the LLM is going to use that information to respond to the user on the front end. Oh, this is, if I say, what is the name of this person in this book? So it's going to pull out that information from the database, and then give it to the LLM. And then the LLM is going to now use it to respond to the user in the front end. So as the conversation is going, there's a context memory, like the history of what has been happening. So if someone asks a question about maybe you say, who's Anthony, and then it's going to tell me who Anthony is based on the data that I have here. And then if I ask, what does he do? So it knows that I'm referring to Anthony. So based on the conversation that we had before, like history. So you're going to pull out what Anthony does. So you're not going to say, what does Anthony do? You can say, what does he do? So he understands the context, based on the memory he has about the conversation. So you can answer, so that's what this memory does. Okay. So here you can see we use a PDF processor. We use PyPDF. We use for the speech to text model, we use Whisper. We use LangChain to build the chain, the conversational chain, and everything. We use OpenAI embedding to to extract the embeddings from the chunks that was splitted. So we use OpenAI embedded to get embeddings. And then we use the OpenAI chat model, we use GPT 3.5 toolbar for the chat model, that gives the user the responses based on what is gotten from the vector store. Then we use the vector store Chroma DB to store those things over there, okay? And then, sorry. Okay, so then we have the Flask API to build the endpoints. So we use the Flask API to build the back end, and then Streamlit for the front end. And then we Dockerize the whole thing into a container, Yeah, so I'm going to talk about the code to explain how the code works. So the code is also available on GitHub, so you can go check it out. But I'm going to try to explain the code by myself here. Okay, I'll share that screen. So here, so I'm just going to run this guy. So I'm using Flask API for the backend, and then I'm using Streamlit for the front end. So I'm just going to open this on the browser so you can actually interact with the AI. Okay, so I'm going to stop sharing the screen and share the browser screen. I think this is it. Okay, so here, this is the RAG AI, Retrieval Augmented Generative AI. So you can just say hi, and then it's going to say, "Oh, how can I assist you today?" So here I can upload a document, a PDF document, and it's going to, pull that document to the database, and I can actually put a link of YouTube video. It's going to convert the video to audio. From the audio, it's going to now convert it to text, and then from the text, I can ask questions around that. The same thing goes here. I can actually put a web link here, like a web page, blog post or something, and then I can put that in the database, and then can ask questions around that information. So here, what I wanted to do here is that I can actually update documents inside the database with I can make updates to already existing files in the database. Here, I can actually delete information from the database. So I'm still working on these three guys. So list the documents available in the database. But for here, this demo, I'm just going to show you about this charts, your data, upload PDF, YouTube video, index YouTube video, and index web content. Okay, so let's start with this first. So I'm going to upload this document. I believe this should be a research paper. So this guy, I'm going to upload and process the PDF. So this is loading here. So I believe this has indexed the PDF. Okay. So what I'm going to do next, is to ask questions around this PDF. So let me see what's PDF's about. He's talking about this guy. So I can just say, Let's see. Tell me about this. So let's see how it's supposed to tell us. So it pulls information about this guy. Okay. Um, so it says this guy is proposed in a research paper by this. So you can actually check that. So these are the guys that did the paper, which corresponds to that. So you can ask questions around this. So paper. So I'm trying to ask the method they use in this paper and see what it's going to tell us. So the method used in the paper is called speaker embedding aware diarization. Because so it tells me about the method they were used in the paper. So I can say, can you summarize the paper? Okay. So wait for it to give us a response. Okay. So it gives a summary of paper. Okay, so I can say what's the contribution search. Okay. So it's going to mention those. It's going to mention the. It's going to mention the. It's mention the contributions of the paper. Reformulating the direction task, utilizing speaker embedding. Incorporating textual information. Experimental results. Okay. So you can see the results research. So here it even gave me. So here it provided the source of the information. Okay, so um so it shows in a real scenario, the method shows a relative improvement of this compared to, so it kind of shows kind of the result of the work. Okay, so what I'm going to do now is I'm going to try switch this up. So if you check here, there's a memory, context memory that was added to this system. So when I said, tell me about this speaker embedding aware neural derivation, it's provided information. So what was the method used in this paper? So I didn't have to mention this again. I just, said what was the method used in this paper. So he was able to capture the context to know that I was actually talking about this work. And then he was able to pull out those information and then say, can you summarize the paper? I didn't mention the title of the paper. It knows that I was talking about the paper. It brought the method that was used in this paper. Same thing happened in the summary. It summarized this paper actually, and also provided the contributions of the research work. So I didn't have to, if you say to some of the chatbots, you need to say explicitly kind of um write, tell it the exact thing you're looking for. But I had to use kind of pronoun or some things to refer to the research work, the title of the research work that was talking about, and then it was able to capture the context to understand what's happening. So how this works, that it actually takes the history of the conversation, and then from there it can actually pick the context of the conversation, and then it's going to respond to you with the right response based on the history of what the conversation of the history of what the conversation is all about. Okay, so we've done the demo for the PDF. I'm going to go for the YouTube link. So I'm going to go to YouTube. Let me see here. So Gemini AI, I'm just going to take one of these guys. Let me take this one that has 5 minutes. Okay. So I'm going to copy the link. I'm going to copy the link, paste it here, and then process it. So this might take a while. I'm going to pause the video so it can actually process this for us. So it can ask that. So what it's going to do is it's going to convert, like I said before, it's going to convert the video to audio from the audio to text, and then index that text information into the database. Okay, so I'm going to explain the whole thing here later. Pause the video. Recording. Okay, so the video is indexed successfully. So what we're going to do is talking about Gemini. So can say, tell me about the Gemini. So it's going to provide that information. Okay. So this is the source where it got information, tutorial on how to use Gemini AI. So you can see here. So it was able to capture that, how to use Gemini AI. So this is where it got the information, to tell you where it got it. So let's see. It's useful. Okay. See. Okay. So it's able to capture those information, also telling us where it's getting it from. Okay. Here I'm going to work on I'm going to look for the web page. So let me say, see, so I'm gonna look for tutorial. I'm gonna see some blog posts. So I'm gonna take this one. Okay. And then I'm going to go to the system, and then it's going to run. I think it shouldn't take time. Okay, so we have that. Okay, so let me see. I hope this works. So tell me about zero. Huh. So you kind of mix something here. So okay, so I'm going to now show you how um so I'm going to show you how the code works, how everything works very well. Okay. So we are able to try the charts, the upload PDF, the index YouTube video, and the index web content. Okay, so let's go to the code itself. So I'm going to stop sharing this. Then okay, so here is the code. Um, here's the code. So maybe I will start from the bottom here, the files from the bottom here, to explain them to you. Okay, so we'll start from here. So this is the vector store. So I try as much as possible to make this as modular as possible. You know, so this is the vector store, the chroma. So this is how it was initialized. So you have the embedding here, then the chroma, and then passing this persistent directory and the embedding function, which is the OpenAI. Okay, so this is how the embedding um, this is how the database was created. You know, the chroma database was so when I call it initialize the database, you know, and then here I have the utils, some of the utils that I use here. So here you see it's a class document loader. So this is how I load the PDF, you know, using the pipe PDF loader, you know, and then I return the documents the contents of the PDF, you know, and then this is the YouTube loader. So you're passing the YouTube, and then you use this OpenAI Whisper parser to extract the to pass the video and then convert the text. So it's normally I have installed a FFmpeg to convert the video to audio, and then from there this OpenAI Whisper is going to help to put it to test and then return the docs. You know, that's the content, that's the transcript. So the same thing happens in this function, the load from web. You know, so if it's a web-based, so it's a web-based loader here. So we use this to extract the content and then return the text. So this is the index. So when you get all those information, you need to index into the database. So one that happened. So we use this code to to index into the database. So we takes the document and the directory for the database, and then we index it. So this is a function for that. And then this is so what I was doing here is to this is not done yet, still working on this. So it's kind of to clear the database content. So to delete all the things from the database. So still working around this. So you can never mind about this. So this is a splitter, document splitter. So what it does is that, so when I have a content, like full text content, I'm going to split those into chunks. So I'm going to split them into 1,500 chunks. Sorry, characters, So yeah, break them into chunks. So each chunk will be up to 1,500 characters. And then, so you can actually tweak this based on your embedding, all those kind of things, can actually tune to what you want based on the tools you're using. And then the chunk overlap is, so if I have Obi is a boy, is going to school, so I can have a chunk overlap that does not, so it's going to, bring out the overlap of Obi is a boy. So if I have Obi is a boy, and then have Ada is a girl, and I want to chunk these guys. So Obi is a boy, is going to be maybe, let's say, 5 characters or 10 characters. For that particular content, Obi is a boy, Ada is a girl. So for the 10, I might say this is 10 or 15. So it's going to collect 15 of the 15 characters of the content, and then the overlap is going to be, so sometimes you might split this guy, and then you might want to capture some text from the chunk size where you have the overlap. So the overlap is going to be kind of to also capture some content from the OB from the 15 characters that you've chunked. So it is going to overlap there. So you're going to get, kind of collect some, overlap some content from the chunk size, So that's how it works. So let me see if I can explain this better. For example, I have B is a boy, and it's a girl. So if I have 15, imagine I have the chunk size. Chunk size is it's equal to 10, and then overlap is equal to 2. So what's going to happen here is that the chunk size, if I count 1, 2, so if I collect 1, 2, 3, 4, 5, 6, 7, 8, 9, imagine this is 10 characters, So I will have the results of the chunk, results of chunk is going to be, let me say, for example, let me say for B, this is a character, put it strange, something like this. And then the overlap, result of overlap, is going to be something like this. So the 2 characters, so it's going to be something like, see, there's a space here. So this is overlap. As I said, so it's going to help the large language model to understand the continuation of the data. So you put a chunk size and also put an overlap to collect some previous data around, the chunk size that you have, so that when you're going to the next chunk size, so you already have, you understand the continuation of the data. So this is how it works. I hope you understand this. Okay, so let's clean up that. So now this is it. So the class to run this on LangChain is recursive characters test splitter. So there are other test splitters you can actually try out, if you want to, if you go to LangChain documentation. So I specify the chunk size, the overlap, the separator. So these are the separators, what's, tells the splitter that there's a new line that says full stop, so how to break the content. So this is what it is to understand how to break the content, whether it's full stop, whether it's space, stuff like that. Okay, so this is how the split document is being written. Okay, so you can see it here, your splitter, then call this guy. Okay, so that's that one. So this is just a document. This is just a document, a PDF. So I don't want to go through that place. So here I have the Streamlit. So this Streamlit, so you can see that here is the backend URLs, the endpoints that I built in the backend. So I'm calling it here so that the Streamlit can consume those to be able to give the user the response based on the input they make. So this is the menu where I wrote the features of the Streamlit, and this is the charts menu, chart your data menu. So inside here, you have the user inputs, the session state, and the chart history. So it captures the user input of the user, what the user inputs into the input box. Okay, and that's the chat input. And then this is just a spinner generating response. So it's kind of a progress status to show when the AI has provided the response. And then you see, so I am calling this request to get this from the back end. So the back end is running this, running the charts, the code for the charts, which is in the back end. So let me just show you that. So this is the charts endpoint where I wrote it, so with the Flask API, kind of user input, the user input is passed to the conversational chain, and then it gets the response and then returns the response. Okay, so that's where you're seeing in the Streamlit. So that's why I pass this URL for this is the endpoint URL for the chat, for the chatting, for the chat service. Okay, for the chat service. Here. Okay. So the next one is the upload PDF. So this is the menu for the upload PDF. Upload PDF. This is the endpoint is consumed, and then this is it here. So the same thing happens to the index video, YouTube video. So this is the URL for the index video, the endpoint for the index video, and then this is also the URL for the index web page URL. Same thing goes for the document, update document, and the delete document, the delete document URL. So I'm going to show, since you've seen the code for the front end, let me go to the back end. Okay, here we wrote the upload method, for the back end, so I've already talked about this one. So this is upload, so we already wrote this somewhere in the util. So I showed this before. So this is a class, and then so this is the function following the PDF. So I'm calling it towards that place to load the file, and then the file is broken into chunks, and then we'll log it log the content of the file to see if it's working, and then index it here. Kind of you can see some error handling here with it here. So these are the routes, so the endpoints for each of them. So the same thing happens to the YouTube index. Get a YouTube URL and then call the load from YouTube from the utils, and then passing the YouTube URL and then split the content. So by that time it has converted to audio to text, split it, and then we index it here into the chroma. So the same thing happens to all of them here into the chroma. Okay, the same thing happens to the web page index. So to index the web page, so we call it, you get a URL, loads call the function from the util, and then split it and then index it. So this is what happens here. Okay, so this is where you did the login code. So there's a function to log the what is happening around it. So we are logging everything. So we're logging most of the places that we want to understand what's happening. So we are logging all of them. And then, okay, so this is just in the notebook I'm trying to, so it doesn't need to see this. There's the README file, and then so this is the Docker. So this is a Docker file for the front end. And then, so this is the Docker for the backend, so we're using, the Python 3.10 slim image, and then we run this command to install this guy in this FFmpeg in the Docker container, because this is what's going to help to convert the video to audio. Okay, so this is the working directory in the container, and then we copy all the things we have from this system into this working directory, and then run the pip install to install all the things in the requirement tst, and then we expose the whole thing to 5,000, to the port of 5,000, right? This guy, and then so this is the code to command to run the backend. So the same thing happens in the Streamlit here. The same Python image, working directory, copy, run the requirement tst, export to port 8501 for the front end, and then this is the command to run the Streamlit. Okay, so with that being said, so this is just the Docker Compose, the version, the service is the rack, backend. So this is how, because with this, it's going to help to connect the front end and the back end together so that they can actually interact, So that's why we need to specify the service and the build context, the Docker file. We specify the Docker file, the ports for this Docker file. We have two Docker we are building, okay, and then the environment. So what's happening here is when a user is pulling this Docker, there's a place that you need to put your OpenAI key so that anybody can actually pull it and then put the OpenAI. Because without the OpenAI key, this is not going to work. That's what you used to do the embedding, chatting the OpenAI chat model. So the same thing happens here. Okay, give me a second. So so this is the front end service, and then this is the Docker file. Specify the Docker file for the front end, and then this is the ports we expose it to. We're mapping the ports, that we expose in the Docker file, mapping it to this place, and then mapping it to mapping it to 8001, sorry, 8501. And then, so this guy, the front end depends on the back end, service. Okay. So here I'll explain from here to here. So this is actually the requirements the requirement. Yeah, the requirement TST. Okay. So I didn't use this guy, so but I wrote it on the I didn't use it again. I wrote it on the conversational chain. So this is the conversational chain. So here you need to pass in the LLM, the vector DB, that's the chroma. So this is the memory I was talking about, so it takes the history of the conversation. And then this is the system template, answer the question, the prompt, kind of, is this, or is this just me building the prompt from here to here, and then creating the prompt, um, the chat prompt template. And then this is the retrieval chain I was talking about, the retrieval technique, where you can actually use the search type of similarity. So when a user makes a query, it searches the database to retrieve so I can change this number to 2, 3, 4. The first, the two closest responses towards the question the person is asking. Okay. And then this is where we build the conversational chain using the conversational retrieval chain. So it takes the LLM, the retriever, and the retriever and the memory, and then the prompt. Okay, and then return that. So at this, we now call all these guys into this place. So you know how coding works. Okay, so this is actually that, and then this is the chat model. So this is where I wrote the function for the chat model. So we use this guy, the GPT 3.5 turbo, and we make the temperature to be 0, so that it's kind of it doesn't give us a random responses. So yeah, kind of maintains the responses, random responses. So if you make the temperature be high, it's going to give you a random responses. So we just try to maintain that here. And then, so this is how this just put in an error handling format here. Okay. And then, so this is where I put the OpenAI. This is the .env where I put the environmental variable where I put the OpenAI, the API key of the OpenAI, and then this is the doc, so all the things that I didn't want to push to Docker, I specify them here, so if you check on the utils, right here on YouTube, so there's a directory to save the YouTube. So it creates this directly by itself when you run the code. So all the YouTube links you provide. So you're going to, the test is going to save them here. So this is for my environment. And then this is the log where I put all the logs, so you can see all the logs here, So here, so this is just the image that I use to explain the content. And then here in the doc, this is the chroma. So this is the chroma here in the log. Okay. Okay, so this is the whole code I've explained to you. And I'll put a link for the code in the GitHub. So this is the whole thing about the code. If you have any question, I'll be happy to answer you. Try to explain this where I can. If you have any question, I'm going to be happy to answer you the question. Okay. Okay, so thank you very much. Thank you very much for listening to me. If you like the video, please share the video, like it, comment, ask your questions on the comment section. So I'm going to be actually, being very serious about creating content around how to build AI. I'm going to be focusing on building, not to build train models from scratch, but how to integrate AI into solutions, how to integrate already built AI into solution. I want to be focusing on that. I want to be focusing on building that to create content for the public. If I have my chance, I will go through training models, which my research papers is going to talk about that. But for this content, I'm going to be make sure that I show how to integrate these models into real world solution, how to use it to solve problems. Thank you very much for joining this session. Thank you.